All right, welcome back. We're on to Graphing Rationals Day 3. As your foldable notes describe, we are using a new term today. That term is called a removable discontinuity. Removable discontinuity is commonly referred to as a hole. And you'll notice that if you have a factor on the top and the bottom which cancels, what you have there is a removable discontinuity or a hole. We're going to use these first three examples in your notes today to demonstrate how that works, and then you will complete the other three on your own for some practice. And then we'll talk more about that tomorrow when you come back to class. Okay, so the first thing you're going to want to do when you see your graph or your equation written in this format is to factor it out. So we're going to start with y equals, I need the two numbers that multiply together to make 4 and then add up to 3. So that's going to be x minus 4 and x plus 1. And that's all over the denominator of x minus 4. The next thing I'm going to do is I'm going to cancel the terms that are congruent, but I'm not going to forget about those because that is where the removable discontinuity occurs. So let's talk about it for a second. In the original function, there is an undefined term at x equals 4. In the simplified equation, there is still an undefined value at x equals 4 because the original function is not linear, it's rational. Okay? The resulting graph is linear, so we're going to draw a straight line. We'll begin here. We have a slope of 1, and we'll go here. Now when I get to the place on the graph which is undefined, which is x equals 4, that's how we find it, we just solve for the denominator, we put an open circle, just like we always do for undefined terms. So then from that place, I'm going to create my graph. Beginning here, it will go off in that direction, and beginning here, it will go in this direction. So the graph is a linear graph with an undefined value with a hole at x equals 4. In this place right here, the original graph would have been a vertical asymptote. So that's the place where if you want to relate it to radii, that's the place where you would determine where the removable discontinuity is located. But radii is not required for this particular problem because the resulting equation is linear, not rational. Remember, radii is the shortcut method for rational graphing, not linear graphing. So in order for you to get this problem completely correct, you would have to show all your steps here, graph this equation here with your open circle at x equals 4. Let's practice again so you guys can get some repetition with this. So I'm going to use the GCF of 5, and I'm going to simplify this to 5 times x minus 3 divided by x minus 3. I'm going to identify my undefined value at x equals 3. Therefore, I've defined my hole, my removable discontinuity, at 3 in this equation right here. This equation is the constant parent function, which is a horizontal line at the y equals 5 y-intercept. So I'm going to go ahead and place my removable discontinuity on that place before graphing my, yep, that's exactly what, before graphing my function. And there we go. Again, radii is not required here because the function after the canceling is linear, and remember we only use that for rational functions. All right, number 3, And the last example we'll go over today, before you guys work on this on your own, is going to be this. So we got properties of exponents. So I'm going to subtract that, and I get y equals x squared. I have to go back here and say, okay, my removable discontinuity is at x equals 0. There's a hole there, so I got to remember to place that on my graph. This is a parabola. This is the parent function of a quadratic, so that means it's going to begin at the origin, so I'm going to place my hole there. I'm going to use my parent function as my guide, over 1 up 1, over 2 up 4, and I'll use symmetry on that one, and then over 3 up 9, use symmetry on this one, and there we go. From here, graph that branch of the parabola upward, and from here, graph that branch of the parabola upward. And there is my equation. There is the graph of that equation with the removable discontinuity there. Take some time now to practice the other three. You will be using Rady on some of them, so please make sure that you're able to do that without any errors, and we will discuss the rest of these problems tomorrow at the beginning of class. Make sure you complete them tonight and have them ready to go tomorrow at the beginning so that you can get full credit for these notes pages.